So today we are going to simulate BPSK data over AWGN channel. So first here we the workspace space. Then I consider the number of bits as n and power 6 semicolon number of bits and the power of the source as ps equal 1. I will normalize power is surface sorry transmission power of the source. Then I need to consider the SNR, transmit SNR in decibel from -3 to consider 15 decibel. Semicolon and SNR in dB. So what we are going to do is from source to destination signal transmit over AWGN channel. This is the network diagram we are going to do, simulate. And then we need to generate BPSK data. So BPSK data generation. This section generates BPSK data. For that we need to generate binary data. Binary data equal we need to use rand src function. So I will show you what is rand src. And src, this is the rand src function. This is the rand src function, so we're going to use this function to generate binary data. And from 1 to n, binary data 0, 1. This is generation of random bits and BPSK data is we need to use this formula to into binary data table function minus 1. So this is the BPSK data. BPSK data. Let's simulate and see what's happening. can see this is the binary data, this is the binary data, and this is the corresponding BPSK data. This is our SNR values from -3 to 15. So we need to loop this data through SNR values. For that we use for loop of the MATLAB. So 1 to length of the SNR step. Then you will see some options and select it. Then you need to close the brackets and always when you open the for loop, at the same time close the bracket. Then you won't get any errors or any confusion. So the other thing is we need to generate some random noise. For that we need to write a function for that. So we are going to write that function. Anyway, you have to write the function at the end of this page, MATLAB page, MATLAB script, and we have to use function n equal AWGN noise. You will need this if you use many times those function, noise function, and end. And this is a random noise. N equal and then 1, n. This is the random noise function. So random AWGN noise. We can see the noise source to destination. Call that noise AWGN that noise and say pass in parameter. So then we need to write the other. This is the equation inside this for loop. So then first we need to calculate the noise power using the SNR decibel values as we introduced earlier. For that, noise power calculation. For that, SNR index K equal 10 to the power SNR dB plus K by 10. This SNR value in linear, and then this is SNR underscore dB equal 10 log is 10 S by N. This is the signal power. Now noise is power. Then we divide by 10 as NR underscore dB divided by 10 equal log 10 base S by N. Then S by N equal 10 base SNR underscore dB by 10. 10 to the power SNR underscore dB by 10. That is what I discussed as calculate SNR value in linear. Then so you have to get the noise power. So noise power N equal signal power by 10 to the power SNR underscore dB by 10. This is what I going to derive to get the noise power. I think you are clear now. So now let's go to the board and noise power. Signal power. So that from the source by SNR K. Calculation of noise power. Check. Let's open the code, and you can see this is the noise power according to the SNR value. According to this, you can understand. So we send signal from source to destination, that is YSD, and let's see what is that. So then we can write an equation for YSD equal, this is source power, then transmitted symbol BPSK symbol X plus noise source to destination. This Y is receive function, and this p mid power of the source is, and x is BPSK data BPSK binary basic key database is +1 or -1, and this is AWGN noise, AWGN noise. It is 0 mean and variance sigma square. So when we consider what's happening here, YSD equal PS x plus NSD. So then you can see the PS is constant, and x is a variable, and n also x is also random variable, n is also random variable. So when we consider the expectation of this equation, YSD equal, I think you know what is expected value, that is mean. That is the mean of this these terms. We can understand what is mean depend on which parameter. Then distribution of the mean. Let's see. YSD equal, we can divide the addition into 2, px plus NSD. So as I told you before, this is 0 mean variance sigma square, so that this part is go to 0. Then YSD equal, we can take this constant out, power constant, PS is so as you can see, this is the mean of the YSD distribution. There is the received signal distribution. So the YSD is also random variable, and expected value of the YSD means the mean of the distribution, and it's depend on this x value, expected value of x. This one, P is a constant, this one is a constant, this the mean. They will depend on this expected value change. We consider this P as constant as 1 equal 1 as a normalized value. Then for to say something normally the AWGN, the form is the received signal y equal x plus n. So this is 0 mu sigma square, and this is plus 1 or minus 1. This one is random variable. So the received signal this one is also a variable. Plus 1 and minus 1 generate randomly, and this is also random variable. Noise, AWGN noise N. And let's go to the previous one. This one. This also it's also changed from between plus 1 and minus 1. This is also random variable. So depend on this distribution, and the square root PS is a constant, and YSD means depend on this one. If I tell you